So good morning, online people. Isaac, Mariana, and P. David. Good morning.
Morning, engineer.
Can we start? Are you ready?
Yes, I think you can start.
Okay, good. Okay, good. So I think now is okay.
Yes, we can hear you.
Okay, good. So I was explaining these settings here of the beam. I started with this B, which is the width of the beam. Okay, so taking an example to this beam here, if I select it to open the property, remember, right click, open the property. I have it here. So I will try to zoom so that you can see the width, how it's changing. For now, I have 300. If I put 200 and update, you see how the width of the beam has been reduced. So this B means the width of the beam. So the H here, it is the height of the beam. So I will use the 3D view so that you will be able to see it clearly. So if I open the property of this beam, you see the H is 500 for now. If I reduced it to be 300, click on update. You see how the height is being reduced. I can again increase it to 500. Take a look here at the 3D view. If I update, now the height have been increased. So the B is the width, then the H is the height of the beam. So let's talk about the eccentricity. So we have two eccentricity for the beam. We have this one. This is the eccentricity in horizontal direction, while EZ is the eccentricity in vertical direction. So I will demonstrate it. Come back to the plan view. Okay. So if I take a beam here, open the property, I'm going to deal with the first E, the first eccentricity in a plane directions. If I put like 50 and update, you see how this beam have been shifted upward. Okay. So if I put a negative value, then it will go downward. Okay. So it is the eccentricity of the beam, okay, in these horizontal directions. Okay. So if I do it for this one, which is somehow vertical, if I open the property, if I put an eccentricity of 50, then it will move to the right or to the left. Okay. If I bring it back to 0, then bring back to 0, update, then it will again go to the center. So this is the first eccentricity. It is the eccentricity in the plane directions, okay, in the horizontal directions of the beam. So the difference between this another eccentricity, to demonstrate it, I will do it in a 3D view. The EZ, now this EZ, it is the eccentricity in the vertical directions. So if I zoom here, you will see that this beam is lying on the same plane as this axis and the column. Okay, but if I change the eccentricity in Z direction, okay, let's put, for instance, 100. If I update, now you see how the beam have moved upward, okay, at this perfection. So if I bring it back to 0, update, you see now the beam is lying, is flashing with the top of the column. So this is the two difference of this eccentricity. This EZ, it is in vertical direction, while E, the first E, it is in horizontal directions. Okay, good. Can you try on your PC, try to deal with these eccentricities so that you can see the difference? Before you do the practice, you can, to apply this eccentricity in vertical direction, you can use the arrow key as we saw on the columns. So if you select a beam, you can use arrow key to apply eccentricity to a beam. Okay, as we saw, it is also applicable on the column. Okay, you see column also, you can apply eccentricity using your arrow key on your keyboard. Okay, so can you try it on your PC to see the difference of this E and EZ before I go on with the remaining settings of the column, of the beam? Okay, so let's go on. If you are done with eccentricities, so let's go on and explore the remaining settings of the beam. No, arrow key, it is the one on your keyboard. Yeah. Okay. So let's go on. So if you have checked well, as long as I select the beam, as long as I select one of the beam, okay, you see I have two ends, I end here and the J end. Okay, so if you select a beam, we will have I end and J end. The I end being the starting point, J end being the end point. So keep in mind this, because we will be needing to use these both ends. So in the future, you may always know what was your I end and what was your J end. Okay. So let me go on and open the property of the beam. So, for example, if you see on the property of this beam, I have the I end and the J end. Okay. So the I end, the coordinates are D4. It means this point here is attached to the axis D and axis 4, D and 4. This is the I end. But the J end is attached to the grid D and 5. D and 5. Okay, so that's the meaning of these coordinates here. So now let's talk about the section angle. You remember we had the section angle on a column. Okay, when we put this angle for the column were rotated. Okay, so the same goes for the beam, but I will demonstrate it in a 3D view for you to see how it will be applied. So if you check well this beam here, my beam is straight. Okay, if you check, it is very straight. But if I open the property and apply a section angle here, let's say 15 degrees, for instance, if I update, you see how the beam have been twisted. You'll be able to see it here. Okay? It have been rotated in a horizontal direction. They have been like twisted. If I bring it back to 0, now it will be vertically straight. Okay, so this is the use of this section angle. You remember for the column, when we used that same option for the column, you remember yesterday, it rotated also the column. You see, like this. So it is the same option for the beam. So the next command is to draw a curved beam. Okay. Yes. Question. Let me come and see. So I'm supporting someone physical. I'm coming back for online people. Okay, so let's go on for the curved beam. So can you try to model a curved beam by your own? Please try. It is the same way as we did for curved axis, if you remember the step. So can you try to model a curved beam? Try. And see if you'll be able to model a curved beam by your own. When people try to model a curved beam, and let me know in the chat box if you were able to do so. Were you able to do a curved beam? Okay. So how about online people? Yes, good. I can see also you managed. So I will demonstrate it. It is similar to the like a curved axis. You remember when we were modeling axis, you have to change to under the insertion method to the curved axis insertion. So it's the same way when you are drawing a beam. Also have to select first this curved beam insertion, then select the first point, select the second point. Sorry, I will repeat it again. Have to select the first point, select the second point. Oh, sorry. Make sure this curved insertion is activated. Then select the first point, second point, then define the length of the curvature. Okay. Then you can always, you have the possibility to press F2 on your keyboard so that you can fill this value. Okay. Then curved axis will be, curved beam will be created. In a 3D view, it will be looking like this. Yeah. So let's take a look to the remaining. Okay, so then the next one is the end release, much more related to the analysis. We come back to this later. You remember when we were on column also, we skipped this. Okay, so I will do the same for the beam as well. Okay, then the supports. Okay, we have supports here. So if you check where we have support at I and support at J, if you click on this drop down menu, you will see none. Okay, it's right and none. And you check well here below, we have I end free and J end free, but which are deactivated. Okay, so that's the like the default settings which comes with the beam when the beam is supported. Okay, to see the difference, we will try to create a cantilever beam so that you'll be able to understand this much better. So let's start by creating a cantilever. So I will be creating cantilever beams at this end here. Okay, So remember, I told you that a beam to be placed, it must have intersection of point at the starting point and at the end point. So if I want to draw a cantilever spanning from this end to somewhere here, so it means here I must have intersection of grids. Okay, so what I will do, I can maybe offset this somewhere here. Okay, so in this case, now I can draw a cantilever beam in between here. So I will go again to the beam, take the normal beam, then the beam will start from here and end here. So this is a cantilever beam because it is not supported at this end. And whenever you draw a cantilever beam, you will automatically see this red triangle. Okay, this red triangle. So if I demonstrate it in a 3D view, if I open the 3D view, this is how it is looking like. Okay, it is cantilever. Okay, this is the beam that I have drawn. Okay, good. So if I select on this cantilever and open its property, you will see automatically that the J end, because this end is the J, the starting one is the I, this is the J end. So in the property, you will see that the J end here have been deactivated, the support here have been deactivated, but the J end free is now activated. Okay, are you able to see it? So it means making one end free, it means simply that it doesn't have any support. Okay, it is cantilever on that side. Are you able to see this? If one end is not supported, there is no column below there. Okay, it is not supported, it is free. It means automatically the software is able to determine that that end is free, and in the property tab, it will automatically check this free end. That's what I mean. But if I open like the property of this beam here, which is supported here, it is not free here. It is also supported at this end. It means it is not free. It means I end and J end both are not free. So if I open the property, you see the software automatically have turned off these free ends. That's what I wanted to make. Okay. So whenever you are dealing with cantilever beam, please, whenever you are dealing with cantilever beam, make sure you have this red triangle on the end which is free. If you model a cantilever beam, okay, and you don't have this red triangle, it means your model is wrong. Okay. Whenever you have a beam which have one end which is not supported, that end which is not supported must have this red triangle. So let's do another example. Let's okay, I will show it to you in a few seconds to come. For now, let's proceed with the remaining properties. Okay, so as we had for the column, you remember we have the general tab and the geometric tab for the column. Now for the beam, we have this general and the 3D tab. So try to move to the 3D tab. Okay, online people, is there any questions so far on your end? Before I proceed with this 3D tab settings, the beam. And people, please confirm if everything is okay before I proceed. Okay, good. Okay, I can see in the chat box that everything is okay. So let me go on. So let's talk about the 3D tab, the settings of the BIM. Okay, so again, we have the plane. Remember, even yesterday we skipped this plane for the column. Okay, so we'll skip it for now. We'll talk about it in the afternoon session after learning how to model plane definitions. Okay, because you remember even yesterday on the column settings, we skipped this. Okay, so we are doing the same for the beam. Okay, we are skipping this. So we have the delta Z at I end, we have delta Z at J end. I guess you already know the delta Z. Okay. So if I put a value on the delta Z I, it means I'm changing this I end here, this one, but in vertical directions. Okay, so for instance, if I put like 1 meter, let me put like 1 meter, click on update. Now I'm raising my I end by 1 meter from its origin. It's like I'm creating now a slant beam. Okay. So if I put a negative value, then it will be going downward. Okay. So you can do the same for the J end if you wish. Okay. So for instance, if I put a negative 1 meter as well here, update, then I will have something like this. Good. So you put them back to 0, then it will come back to its initial position. Okay. So there is something I want to show you here. Take a look. Okay. You see now I have a normal beam here sitting on the right of the plane of the story here. If I select it, okay, you see, first of all, if I select it and go to the property in general, you see I don't have any end which is free. Both ends are supported by columns. That's true. Okay. But if I go to the 3D view and try to raise one end, let's say the J end by 1 meter, click on update, you see now this end is free, is no longer supported by the column. Okay, you see this end, it is free. And if you check well, we have that triangle mark that I was saying here at the top. If I do like this, maybe you'll be able to see the triangle. Okay, if I go to the plan view, it is this. I also have that triangle. So this triangle means that this end is free, is not supported. So if I try to open the property of this beam, you see automatically the software have checked the J end to be free. Okay. So in this case, I'm sure that I have well modeled my beam, because in the analysis and design, it will be considered free at this end. Okay. But if you have a suspended beam like this and you don't have this triangle, it will be analyzed and designed as it is sitting on a column, which will be wrong. So make sure always when we have this kind of cantilever beams, you have always this triangle marking, showing you that it is free. If I bring back to its normal position by removing this offset here, update, you see automatically the triangle, that triangle have disappeared. Okay, so please, whenever you will be modeling cantilever beams, make sure you have this triangle. So it is on the end which is free, and it is pointing where there is a support. So try to deal with this. Okay. Another thing I can let you know here. Okay. Sometimes when you are modeling, okay, for the first time, you may draw a beam, delete it, redraw it again as many times as you want. And sometimes you may, let's take an example for here and see if it will be possible. Maybe at the first time you modeled this beam as a cantilever, and later on you decide to put a column at this end. Okay, so you decide to put a column maybe here. If you put a column, you see automatically the triangle has gone. If you delete this column, it will come back. Okay, so sometimes you may put a column here and you see that this red triangle remains there. Okay, so it will be a wrong model. So in that case, if you want to remove that triangle which was here, you can always come and open the property and make sure you uncheck the free ends. Okay. Or another way, you can select the beam, right click. Okay, if you right click, you'll see mark free end of cantilever beam. You have three options. You have both ends are supported. We have one end which is I is free. We have another option, J end is free. So for instance, if I do J end is free like this, you see it is not able to put the marker because the software knows that even though I'm saying that this cantilever is free, I mean this beam is free, yet there is a column, it is not free. Okay. So you see the software itself is intelligent enough to know whether the beam is free so that it can mark it as a free, or remove the free end whenever the beam is sitting on any given support. Okay. So can you try, find people and see all of this before we go on? So for 9 people, how far are you? Are you okay with what we have learned in this morning regarding the beam? Is there any question on your side?
Yes, sorry, I have one question. Hello?
Yes, Isaac.
Yes, I want to know how to draw a cantilever with a tapered end.
A cantilever with?
Tapered end.
Oh, tapered end. Tapered end of a cantilever is not yet supported in Prota. So
Okay.
Prota doesn't support tapered end of a beam.
Okay.
So it means the height of at the I end and J end must be the same.
Okay.
Yeah. Any other question online? Okay, so if there is no other question, so we'll have a break, 30 minutes, then we'll come back. Okay. 9 people, can you confirm if my audible is the screen visible so that we can go on?
Yes, we can hear you. The screen can see.
Okay, good. So let's proceed with our training. So so far we have covered to model the grid lines, columns, wall, and beam. Okay. So now we are going to move to the slab, solid slab. Okay. So Protastructure 2025 can support different type of slabs. modeling and analysis and design. Solid slab, grid slab, flat slab. But what we have to cover on our curriculum is the solid slab. So let's go on with the solid slab. So again, to model the solid slab, it's a matter of going to the modeling tab here at the top. Under reinforced concrete members, locate the slab command. Okay. Then click on slab. If you click on slab for the first time, you will have this warning. Okay. You have this pop-up message saying that load cases must be defined before load assignment. Would you like to define load cases? Okay. So if you click no, it means nothing will happen. The property for the slab will not be loaded so that you can place slabs. Okay. The same goes even you do it in any plan. Okay. So the only way to model the slab for the first time is to accept this condition and then define the load cases. Okay. So if I click on yes, then you will have this load combination editor, where you have to define load cases that you will be using in your project, and load combination as well. Okay. So there is a way the software have provided to automatically create this kind of load combinations is by passing to loading generator. Okay. So this is more related. If I click on load generator, I will have this table again, okay, where I have to set the load combinations, load cases and combinations. Okay. We have vertical load combinations, we have horizontal combinations, so we have to create the load, those load combinations. So we will have tomorrow, I guess tomorrow sessions, we will cover all these and explain all these settings, okay, everything here. Okay, but I don't want to go deeper now, okay, because we are still dealing with modeling. So what I want you to do, just click on OK. You will have this kind of load combination. I will explain it tomorrow when we will be reaching the loading part and analysis. Then click OK again. Then you will be able to have this slab property. Okay. So tomorrow we will go deeply in all those settings to set load combinations. Okay. So for now we are only focusing on modeling. So click on OK, so that you can have these slab properties. Please confirm, online people, if you were able to have this slab property open before I go on. Good. Okay. You can see that we are together, online people. That's fantastic. Okay. So let's go on and start modeling our slab. So for the slab, I will first explain these settings. Okay, Mariana left behind. Okay, I will repeat. Yes, sure. So when you click on slab, this slab, okay, you will have a warning, okay, saying that you have to set load combinations. Okay, click on yes. If you click on yes, you will see something like this. You see a table like this. Okay. Wait, I'm coming. If you see a table like this, then click on load generator. Okay. You will see different settings just we will explain all these settings tomorrow. Okay, what I want you to do for now, just click on OK and click on OK again, and then you'll be able to see this property, this slab property. Mariana, if we are together now. Okay, good. I've confirmed that we are together now. So let's go on, proceed. So I'm starting by explaining these settings here before starting placing the slab. So as usual, the first one is the label, which is the name, the naming. Okay, you are already familiar with label for all members that we have seen so far. Then the second here is the type. So if you click on type, you will see various type of slabs. Okay, this is very, very important. Okay, so you know that we have different kind of type slabs. Okay, depending on continuity of the slab. Okay. So what does this means? For instance, is there any question? Do you have a question? So excuse me, online people, I have to support someone here physically. Okay, I'm back. So I was explaining this type of slab. Okay, so we have different type of slab depending on the continuity of the slab. Okay. So for instance, if we take an example for type 1, so you will select type 1 when you are going to model a slab which is continuous on all 4 edges. Okay. So you will see the hatched side. This hatched side means that that side is continuous. Okay. So for instance, you see on my model here, if I want to put a slab here, okay, if I want to model this slab here, suppose here I will be having slab on this edge, I will be having another slab, a slab here, and a slab here. So this will be like a slab which is in the middle. So it means all edges are continuous. So in that case, this will be type 1. Okay. So let's say I want to model this slab in this panel. So I will only have slab at this edge and at this edge, because I will not have slab. Okay, so it means this type of slab will be continuous on one edge and on another edge. So 2 edges will be continuous, and 2 edges here outside will be discontinuous. Okay, so this will be type 4, because if you can see type 4 have 2 edges which is continuous, the hatched one, and 2 edges which is discontinuous. So depending on the continuity of the slab, now you know which type to choose here. Good. Is it understandable? So I will repeat again one more time. For the slab, okay, let me draw another beams here so that you can see. Okay. So talking on this slab here. Okay, don't do this. Okay, I'm just explaining. Okay. Don't do this for now. Just wait. Okay. Just wait. Okay. I'm just explaining. So you see this slab here. Okay, I'm going to define the type of this slab. Because I have slab on all 4 edges, it means this slab here in the middle, it is continuous on this edge on this edge, this one, and this one. Okay, so it is in the middle. So the type will be type 1, because under type 1, you see it is hatched on all 4 edges. It means it is continuous on all 4 edges. Okay. When I will be dealing with this slab here in this corner, it is only continuous on this side because I have another slab here. It is continuous on this side because I have another slab here, but it is discontinuous on these 2 edges. Okay. So this must be type 4, because the type 4, as you can see here on this figure, it is continuous on 2 edges and it is discontinuous on the other 2 edges. So let's take this slab as an example. Okay, this one. So it is continuous on 3 edges, right? And discontinuous on 1 edge. So it must be which kind of type? Which kind of type? Okay, some are saying 3, some are saying 2. So the difference between 2 and 3, on 2, the edge which is discontinuous is the longest one. Okay, for 3, the edge which is discontinuous is the shortest one. So this is the shortest one, because here I have 3 meters, while here I have 4 meters. So this edge means this must be type 3. Okay, and so on and so on. So that's the use of these types. Okay. Then we have H. Online people, can you confirm if everything is understandable regarding this type of slab? Okay, good. Well understood. Good, good. So the next part is about the H. Good, good. I can see your response online, people. Everything is okay. Great. So the H here is the height of the slab. Okay, so if I zoom one of the slab that I have modeled so far, you see that H is 120. It means the height of the slab. Okay. Now we have this level, this reference level. By default, it is 0. So I'm going to explain this. So using the 3D. Okay. So if I open my 3D, okay, don't bother yourself with placing slab. We'll give you time to place slab after explaining everything. Okay. So by default, that's how the slab should look like. It is flashing with the beams and column, okay, at the top. That's because under the reference level, it is 0, okay. But if you put a value, maybe negative 100 or negative 50, and update, now you see the slab have been lowered down. Okay, 50 millimeter. At 0, it was flashing with the beam here. If I put a negative value, okay, negative 50, for instance, it will go down. So if I put a positive value, 50, if I put 0, it will come here. If I put 50, update, then it will go upward like this. Okay, so this like giving a little bit of offset in a Z direction. So that's the level, the meaning of this value here. Okay, so I will bring back to it to 0, so that can flash with it. The next one is apply Z to analytical model. So by default, the software, the program will always consider the slab flashing with the beam like it is like now. So if you decide to apply this offset, okay, you must make sure that you tick this one, so that in the analysis the software will know that the slab have been shifted down or upward. Okay, so if you don't click this under the analysis, the software will always assume that the slab is flashing with the beam. If you have changed the reference, yes. Now here is the concrete cover. You can put the concrete cover. Okay. Then the next one is the design angle. So this design angle is a little bit different to those we have seen when we were talking about the column and the beam. You remember when we were on, let me do it in a plan view so that you can see it. Remember the model when we changed the angle here, the column were rotated. You remember? The geometry of the column were being rotated. When we were on beam, you do also remember when we were on beam and changed the section angle, it was twisted. You remember? But it is different for the slab, because if you set the slab and change the angle, let's say 15, and update, the slab will not be like rotated or twisted. Okay, so what does this mean? Okay, when it comes to the slab, when you are changing this degree here, this angle, you are not changing the physical model of the slab, the geometry of the slab, but you are changing the orientation of the reinforcement, the rebars, the steel bar inside the slab. Okay, right? So when you apply an angle here, so it means you are changing the reinforcement, the direction. Okay, so for instance, if I put 45 degree like this, okay, so maybe I will use a polyline to show you. The reinforcement will be like this. Okay, it will be like this. Okay, it will be along this line that I have drawn. Okay, because I have put the angle 45 degrees. But if I let it be 0, this angle to be 0, now I'm sure that the reinforcement will be in this direction. Okay? So that's the meaning of the angle out here. Okay, good. So the next one is the label position. Okay, the label position. This label position is just you see when we model a slab, we have this label here. Say that 1S5 means 1 for 1, S for the slab. Then this is the slab number 5 on the story 1. Okay, this H means this is the height of the slab. So you see, this is the label. By default, this label is in the center of the slab. Okay, so you can change the position using this. So if I click one at this top corner and update, you see now it have changed the direction. I can put in this corner here. I can put it on the lower side here, on this lower side. So it is just changing the position of this label only. Okay, good. So can you confirm if we are together? So I have explained all the above settings. So let's go on to this last one, which is the insertion, and which is the most important, if I can say, when modeling Slab. Okay, these insertion methods. So under the insertion method, if you click on this arrow, we have 5 different insertion methods. So we are going to see them one by one. Okay. Take like 2 minutes to explore these kind of settings I were explaining. Then I will proceed and explain these insertion methods you have. I hope everything is okay. I can proceed with this insertion method. Okay. So to explain this, I will delete the slab for now. So take a look here, please. I want to show you something. Suppose I want to delete all these slabs. Okay. I can select one slab and delete it using a delete key on my keyboard, and do the same, but it will take like a very long time deleting slab 1. Okay? I can decide to select this. When I hold the key on my keyboard, Control, I can select multiple slabs. Okay, good. But I also think this will be not be a good way if I have like many slabs to delete. Okay. Another way that I wanted to show you that we didn't cover so far is using the structure tree. You remember when we were starting the training yesterday, I informed you that whatever member we are drawing here in the display will be also located in the structure tree. So if you have the structure tree, okay, here in structure tree, under story 1, you'll see we have different members: column, shear wall, beam, slab, and so on. So every member which have a triangle before it means it have member inside. Okay. So for example, if I click on this triangle before the column, it will expand and I will be able to see all the columns inside my model. Okay, you see the list from this one all the way here. All these are the columns that I have modeled. Okay. If I these are the shear wall that I have in my model. Okay. So for instance, let me try to zoom. You see 1C1, column 1C1. If I select this, you see here in structure tree, it has also been selected automatically. Okay. So for instance, if I select column 14 from the list here, you see automatically in the plan view it have been also been selected. Okay. So it means if I want to select all the column in my model for the story 1, instead of selecting one, holding Control, select another one, and so on, I can use the structure tree, select the first, click Shift, select the last one, then all the columns will be selected. Okay. It will be the easiest way, I think. Okay. So you remember I wanted to delete all my slabs, so I will make sure that I locate slabs. Okay. Now I select the first slab, hold down the Shift key, select the last one, then all slab will be selected. Then I can delete using my delete key on my keyboard. Then all the slab will be deleted. Okay, so you see that you can use structure tree to locate the members. So as we go with the tree, I'll give you some tips to help you to try to model very fast. So let's go with the slab. So I want everyone to please follow here. Online people, follow here. I will give you time to do practices, because this is very crucial, what I'm going to say. So we have insertion method. So when to model a slab, of course, you must go to the modeling tab. This is the first step. Select the slab. This is the second step. And define the settings as we have explained. Okay. Then lastly, you have to choose the insertion method. So I mentioned that we have insertion method. So we are going to see method one by one. Okay. First one, okay, this first one is the axis region. Okay. To explain, I will with the BIM region. Okay. So I'm starting with the BIM region. So after setting all the settings, I'm selecting the BIM region. Okay, it is the one which is selected here. So take a look. Whenever I bring my region, you see some like a highlight of the boundary of the slab. Are you able to see it? As long as I bring it, it will be somehow highlighted. If I go here, now you see the boundary is highlighted here. If I move the cursor inside here, it will be highlighted. So it means the software is detecting the boundary of the slab being beams. So it means the contour of the slab is because I have selected the beam region. Good. So after having this highlight, it's just a matter of left click on your mouse, then the slab will be placed, taking the boundary of the slab being beams. Okay, I think it is understandable. For the demonstration, let me offset this axis here. Now I'm going to repeat the same procedure, but now I will check axis region. So for the axis region, now the software will detect the boundary of the slab being axis, being grids. Okay. So now here, if I bring the cursor inside here, you see the boundary of the slab is limited to this, because here we have axis. So I can put a slab here or a slab. So if I click here, see the slab will be limited only till this axis that I have created F. But if I change here and put beam region, if I click here, the slab will be in the entire panel here, considering the beam as the boundary of the slab. I think it is clear the difference between the beam region and the axis region. For the axis region, the software detects the boundary of the slab being axis. On the beam region, the software considers the beams being the boundary of the slab. Good. Then, can you feel I go with the 3 remaining one? Can you try to practice? Let's take like 2 minutes, 3 minutes. Difference between the axis region and the beam region. Let's take 2 minutes. Do that. And then I will explain the 3 remaining. Online people do the same. Practice on your computer so that you can see the difference between axis region and beam region. Okay, so there is a question online. Chedi, can you reduce the slab? So I can see an axis. Yes, the axis and the grids are the same, so we can just see. Okay, it is the same. Good. So let's go on. So let's go see the remaining three options. The next is to pick axis. Okay. So when you use pick axis, now you have to manually select every axis which is next to the boundary of the slab. Okay. So let's do it. If I take a look here, if I click on pick axis, what I will do, let's suppose I want to put a slab inside this panel. So it means I will have to pick every axis making the boundary of the slab. What you have to keep in mind is that you must select them in the anti-clockwise direction. Good, anti-clockwise direction. You remember? I told you that for Protastructure, always the left bottom part is the origin. Okay. So if you are measuring angles, you are taking the horizontal as the origin, and you are going in anti-clockwise direction, the positive direction. So the same applies here. If I want to put a slab inside this panel using a pick axis, now I will have to pick all the four axes which are making the boundary of this slab in anti-clockwise direction. So let's do it together. Then I will select the first axis or the first grid. Okay, maybe this one, maybe this one, this or this. It's up to you. You can select you can start by selecting any axis you want. So let me select this one at the bottom first. So I will have to zoom a little bit so that I'm sure that I'm selecting a grid. Okay, this one. So I will select. To make sure that it has been selected, another insertion method, you will see the name C. It means this grid C has been selected. So if this was the first one I selected, the second one I have to select in anti-clockwise direction must be this axis here. Okay, which is axis 5. Okay, so I will zoom again, select, make sure that it has been selected. Then the next one in anti-clockwise direction will be this one at the top, which is D. Then I will zoom and select. Make sure that D is selected. Then the last one in anti-clockwise direction is this one. Okay? So I will have to zoom and select. It's not mandatory to select it from here. You can even select it outside here. It's okay. As long as you select it axis, it's okay. So I will select 4. You see now all the 4 axes have been selected. So to end the command, I have to select the first grid that I have selected. To C. You remember this one, C. So I will have to come back and select this one to terminate the command. So if I select, automatically this will be created. So I will repeat again. So to make it more interesting, I will delete this BIM. Let's suppose I want now slab on all this panel. So you see all this panel. So I'll take slab. I'm going to use pick axis. So I will select the first axis that I want. Let's say this one. Make sure it is selected. The next one in anti-clockwise direction will be this one. Okay, which is axis 4. Then select it. Make sure it is selected. The next one will be this one, this horizontal one, the top. Zoom, select, make sure it is selected. The last one will be this vertical one. Zoom, select, make sure it is selected. Then to terminate to end the command, I have to select the first one I selected, which was C. This one at the bottom. Then select. Now the slab will be covering all these. Okay, so can you try pick axis? Try pick axis. Try using pick axis and see. Chedi have a problem, picks all 4 axes by itself. No, please make sure that here under the insertion method you have selected pick axis, not axis region. Okay, so it is different. Check pick axis, not axis region. So you are using pick axis. So if you select pick axis, now you will be able to select those axes by yourself, not. So try it and see. Chedi, try. Because we have it. I checked pick axis and update. No. So what you have to do, okay? First of all, make sure nothing is selected. Then select the slab, okay, here. Then change to pick axis. Then start picking axis, okay? So you don't use it when you have like one slab selected, then go like this and change. No, you have to first select the slab, then select pick axis here, then start picking axis where you want to put the slab. So try it and let me know if it's working on. This is Chedi, good. I can see now it is done. Good. Congratulations. Is there any other question online, or should I proceed with pick point? You have a question? So let me support someone here physically. I will be back. So online people, here in class we had a concern about this insertion method. Okay, so please follow. Please. So please follow a bit. Here, this insertion method. Okay. So this insertion method doesn't affect your analysis or design calculations. Okay. These are just a way of placing slabs, modeling slab. So if someone decides to use axis region and model all the slab in the model, it's okay. Okay, so if another one use a beam region, while another one have used axis region, you will have the same result. It will not affect any. However, I'm explaining this because depending on the structure you'll be working on, you may find that beam region are not enough to place your beams. Your slab. For instance, you have a scenario like this. From the architecture model, the slab is only on this part. So if you know to use only beam region, then it will be wrong because you'll be always placing slab in the whole part. Yet from the architecture model, the slab is only on this side. So it is important that you know how to use also axis region, so that if you meet a scenario like this, you will be able to place slab on this part only like this. So that's the only reason. So this, whenever type of insertion method you may use, it's up to you. It will not affect the analysis or design. Okay, just only modeling. Good. So if you are done with the pick axis, the last one, the next one is the pick point. It is similar to pick axis. Okay, the only difference is that instead of picking axis, I will be picking point. So for instance, if I want to put a panel in this slab in this panel, using pick point, I will have to select the first point here, second one, the third is this one, reaching on the fourth one, then the slab will automatically be placed. Okay. So it is like pick axis, but in this scenario, we'll be picking point instead of axis. Then the last one is pick closed slab edge. Okay. To use this last one, you have to have a slab, a closed slab edges. So you remember yesterday we talked about these polyline and line things here. Okay. So for instance, if I draw like a rectangle, let me do it here outside. It's okay. These are just lines. Okay. Even if I go in the 3D view, you see it is lines. Okay. So you can first of all draw a closed slab edge like this one, then insert a slab inside these lines. So if I click on slab and check the pick closed slab edges, okay. If I click on these lines, now I will have the slab inside those closed slab edge like this one. So this will help you to draw to model slab which are somehow irregular. You may have an irregular shape, okay, depending on the geometry of your slab. I mean your structure, and using polylines, you can convert this into a slab. Okay. Good. So let's take like a tangible example. Let me delete this. Let's suppose I have like a slab which is looking like, let's say, maybe it is like this. Okay, so you had a design which was looking like this. So using the above Slant method, there is no method you can use to put slab here. So, but if you decide to draw first of all these lines and choose the pick closed slab edges and come and pick on one. Sorry. I pick closed slab edge. So I'm getting a message warning telling me that the slab, the edges must be closed. So it is like a free side. It is not closed here down. That's why it is not being. But if I do a polyline, I don't know some. Okay, now let's try this. Now you see I have the slab, so because it was closed. Okay. So in a 3D view, you see I have the slab, irregular slab, looking like this. So this may help you when you have such kind of scenario of slabs and whatever. So those were the 5 different insertion methods. So it is good that you be aware of each and every one. So depending on the result you want to achieve, you may choose to use one of these. Okay. So are we good so far? So we are done with all these settings of the slab here, and we have seen, as we have seen on the previous members, the slab also have two tabs here. We have the general one and the load tab. Okay. So we'll come back to the load tab the day after tomorrow, I think, after we reach the loading tab. When we'll be starting working with loading, we'll come back on this. Okay. So in Protastructure, you can have openings in the slab. Okay, so we are going to see how to model some openings. Okay, in the solid slab. Okay, so for example, I want to create a rectangle opening inside this solid slab that I have here. So how to achieve it? Still under the modeling tab, under the reinforced concrete members, you will see slab opening on top. It is a small icon here at the top. Please locate that. Slab opening. Are we able to see under the modeling tab? Are we able to locate it? Okay. So I will click on slab opening, then you'll have a dialog box as usual. Okay. So you will have to put the measurement B1 and B2 because it is a rectangular one that we are going to create. Okay. Make sure that you are not left behind. Under modeling tab, then locate the slab opening. Take a look there. Okay. Slab open. Okay, so you have to put the value of B1 and B2. Okay, B1, let's suppose this may be 100. Okay, so you can even automatically see the preview. Let me use 500 so that can be much visible. You see the preview of the openings. Okay. So after putting the size of the openings, now the next thing, okay, take a look here. Here there is a hint in Protastructure 2025. So after there is like information box here at the bottom. Okay. So whenever you are modeling or you are doing any actions, there is a prompt here of text showing you the next step of what you have to do next. So after doing this, after filling all the information, you can see here it is right to pick the reference point of the slab. So what I have to do is to pick the reference. The reference may be any point, okay? Any point on your model. So for my case, let me take this as a reference. For instance, I have selected this as a reference. Now I can go and put the opening where I want. So if I click, for instance, here, now the opening will be placed. If I go to the 3D view, now I have an opening in my slab. Okay. You can also use, after selecting this, let me this time take this as a reference point. You can use the F2 on your keyboard to fill in what? To fill the exact distance if you wish. Okay. Good. So for instance, if I put 1.5 meter, click enter. Now this distance is locked of 1.5. Then I can move and place where I want. Another thing here, when you place F2, you have the option to put the X value and Y value, taking the point that you have taken as reference from the point that you have taken as a reference. For instance, for example, if this is a reference, Then I can put the value, maybe say 2 meter as X, then comma, put the value of Y, then we put 2 meter again, and click on enter. So let me repeat it again. Take this and take reference point, then place F2 on your keyboard, 2 meter in X direction, and then 2 meter in Y direction. So wait, 2 meter. Then so it is not working. Let me check why. So in the meantime, you can try to put this opening using the reference that I have shown. You can use this. You can change the type. You can maybe say now you have a circular. You need a circular one. Take reference and put it here. Okay. So you can try. For the rectangular side, you have also you can even change the angle. Okay, so if I put 45, now you see how it have been rotated to 45 degree. If I put 0, now it will be a normal square with no angle. So try and see if you'll be able to place these openings in the slab. Okay, is it working? So let me demonstrate the one of using X and Y again. So if I take slab openings here, I define if it is a circular or rectangular, put the diameter. If I take a reference, okay, let's zoom it here, then place F2 on your keyboard. Instead of putting the length, we are going to use like a coordinate, X and Y value. So I will put 2 meter, for instance, comma 2 meter. It means if this is a reference, the 2 meter will be measured from the reference point where I have selected. So it will be 2 meter away and 2 meter above. So the circle must be somewhere around here. Okay, so after putting the value of 2 meter, then if I click on enter, now you see the hole have been created. So it means this hole is 2 meter away and 2 meter away from the vertical and horizontal direction. So it's if I wish I can repeat. So I will maybe delete this, repeat it. So select the slab opening, put the value maybe of the opening. Let me this time use a rectangle one, 500 by 500. You can see the preview. So you can take any reference you want. So I'm taking a reference here. Okay, but note that the measurement that I'm going to put as a value will be measured from the reference point that I have selected. So I'll press F2 on my keyboard, then I'll input those values, 2 meter, comma 2 meter. So it means 2 meter, the first number 2 meter is for X, then it will be moved 2 meter in X direction, then 2 meter from Y direction. Then click enter, then it will be placed as this. So as a demonstration, you can always measure between objects if you want in Prota. So if you make sure nothing is selected, right click, then you see measure. Or you can use Control R, Control on your keyboard plus R key. Okay, so I will measure. You remember I took this as a reference, so it means from this to this point in X direction must be 2 meters. So from this point all the way to here, you can see that it is 2 meters here. The distance is 2 meters. So again, from this point all the way to this one, also it is 2 meters. So because of the origin was this, okay? So that's how you can precisely model your openings. Then, lastly, we have a drop. Again, passing through the openings, slab opening. Now we have a drop region. So instead of putting a hole, an exact hole, we are going to put a drop. So I will open a drop, again, resize and put the size, let's say 500. But this time will not be a hole, an opening, it will be a drop. So if I check this, I have to define a drop height, okay? Let's say -50. So in this case, if I model this drop here, okay, it is no longer a hole, it is a drop. So let's view it in a 3D view. See, it is no longer a hole, but just a drop in a slab. Okay. So the first one was just holes, okay, but this one is just a drop of -50 millimeter. So that's it about the drop and openings in slabs. Drops, okay, let me repeat on drops. So again, I will pass through the slab opening. I will have to put the value of the size of the opening, okay. But I will make sure now I checked on this drop region definition. Must be checked. So in the drop, I have to fill the value how much I want to go down. Because we are going down, it must be negative. Okay. So if you put a positive value, it will go up instead of going down. Let's do it. If I put like slab drop 500 as a size here, then the drop I will put 50. Draw a drop somewhere here. If I go to 3D, you see it is upward because it is a positive value. But if I put a negative value and update, now it will be a drop. This is a rectangle. So you want to make it from down. I don't think this can be applicable. No. It is always from top. So let's go on. Let's go on, and the next thing I want to show you is very interesting. So let me complete my beams here so that before demonstrating the next tips that I want to show you. Okay, so there is a fastest way. Okay, always in Protastructure there is an easiest way and fastest way of doing things. Okay, so let's suppose you are designing like a building, and all the panel, the slab have the same property. It means they have the same thickness, okay, or loading or whatever. So instead of placing a slab one by one in each panel, you want to automatically fit the slab all along your plan. So there is an easiest way of doing that. So that's what we are going to do. So to demonstrate that, I will delete all the slab that I have. Okay. I will delete all the slab, but I will take that opportunity to show you another way of selecting multiple things. You remember I have shown you how you can select multiple, for instance, multiple slab using a control key on your keyboard. You have seen how you can use the structure tree to select slab. Now this time I want you to show you how you can select multiple elements using filter command. Okay. So the filter command is located here at the top. If you activate the filter command, you'll see everything is selected here. So make sure you click on this filter, this selection filter, everything is selected. So button to select everything. So if you click on the last button, it will deselect everything. Okay. This one. No, click on this button. This one. Okay. Good. If you click there again, everything will select. If you click, everything will be selected. So for my case, I want only to select slab. So I will click on slab. Okay. So we should come here, click, then you have something like this. Okay. So make sure only slab are selected. So in this time, even though I select everything like this, only slab will be selected. Then I can delete using my key on your keyboard. Okay. Try it. So let me repeat again. So you have to activate this filter command to have something like this. Make sure to use this last button, select the select all, to make sure nothing is selected, and only select slab because we want to select only slab. So if you click on BIM, for instance, now if you select only beams will be selected. But for my case, I want to select only slab. That's why I'm making only slab selected. Then I will select everything here. Slab will be selected. Okay. Then I can delete them. So click complete. Then slab will be deleted. So I'm also going to delete these lines here that I have created. So I have something like this. So online people, can you try to use the filter command and see how? So can we go on? So we were about, I was about to show you how you can automatically place slab in your panels automatically. So the software we're going to help, instead of placing slab panel by panel. Okay. So how to do so? Again, under the modeling tab. Okay. you will see insert slab automatically. It is the command which is under the slab opening that we were using. You will see insert slab automatically. Okay. Good. Are you able to see insert slab automatically? It is under where we had the slab openings. Yeah. Can you do that? Can you try to do this? Because it's your first time seeing this, please read the instructions here, the usage, and try to do it and see if you will be able to place a slab automatically. So the command is here. Under the slab opening, you will see insert slab automatically. Put your cursor to hover it. You will see the usage, how this command is used. Try to read these steps 1, 2, and 3, and insert slab automatically and see if it will be possible. It is 3 steps. The first step, you have to open the slab property window. After opening the slab property window, the second step will be to run this command. It means to click there. Then automatically the slab will be inserted in all those areas. Were you able to do that? Okay, some yes, others no. So let's try to do it together. So as you can see, the first step was to open the slab property window. Then the second step was to run this command. So opening the slab property window, it's just clicking on slab, then the slab property window will open. Okay, so you must make sure that you have set all these as you wish. Okay, the settings. Then the second step was to run the command. Just click here. So if I click here, automatically the slab will be filled in my model. Okay. So I will repeat again. The first command is to open the slab, do all the changes that you want to do in the properties here, then click insert slab automatically, then they will be inserted. Good. So if you are modeling a very huge building, it is not mandatory to set panel by panel. You can use this method. So the type of slab will be the one you selected here. So it means all my slab type is type 1. So which is wrong. So let's see how we can define the slab type automatically. Okay. Good. So to define the slab type automatically, let's do this. It is also a command which is under the command that we're using. The next one, you see set slab type automatically. Then you try. The first step is to set the slab type automatically button, to click on it. Then specify the option such as continuity tolerance. So let's do it together. It will be better. So doing this, take a look. If I open the property of this slab, it is type 1. If I open the next one, it is type 1. Any slab that I may open, it have been named as type 1, okay, which is wrong. Okay, every slab here is type 1, which is wrong. So we're going to adjust this automatically. So you already know that this would have been type, which type? Type 4. Okay, this would have been type 4. Okay, so we see at the end if these really have changed to type 4. So to do that, go to the modeling tab again. Then under where we had the slab, insert slab automatically, we'll see set slab type automatically. Click there, and we have this dialog box. Okay. So for now, let's keep this percentage. I will explain it in a few minutes to come. However, see these 3 options that we have. The first one is to apply this apply to selected slab only. So it means if you run this command after selecting some few slab, it will be applied only on those slabs which are selected. The second option is to apply to all slab in a story. It means it will be applicable to all slab within one story, one floor. The last one is to apply to all slab in the model. So it will be applicable to all slab you have in your project. So you will choose one depending on what you want to achieve. Okay. So I have one story, so I will do apply to all slab in the story. Then click on OK. If I click on OK, I will have like a message. It is like just a summary. Okay. So for my case, I have 2 types. I have unspecified slab and specified slab. Okay. Unspecified slab, it is slab 12. I will show you the slab 12. So if you check where in my message it is written, edge count are greater than 4. I will explain this in a few seconds. Then under the specified slab, you will see, for instance, for my case, I have slab number 1 have been changed to type 4. Slab number 2 have been changed to type 3, and so on. It's like the summary of what have been done. Okay. Then I will click OK. It's okay. Then I'm going to double check and see if my slab type have been changed. You remember this was type 1 before, but if I open the property now, it's type 4. It's no longer type 1. If I check this, it is type 3, which is correct. If I check this, it has been changed to type 3, good, correct. If I check this, it has been changed to type 4, which is correct, and so on. Okay. It means all my slabs have been assigned the right slab type. However, in the message, if you remember, I have a message saying that slab type 12 was unspecified. Okay, this slab type 12. Okay, it means the software was not able to define which type was that. That's the meaning. Okay. So the reason is because I have this curved beam here. Okay. So it means this defining the slab type only works when we have 4 edges. Okay. This kind of rectangle and square slabs. Okay. If you have something like this with this kind of curve, if you have something like a triangle slab and whatever, these the slab types, these ones are not applicable. Okay. Is that clear? Good. So I told you that the slab type, okay, this slab type will affect the design, okay? And the software and even ourselves, we are not able to define the type of this slab. So how this slab will be designed? What do you think? We mentioned that during the slab design, it is very important to apply the right slab type, because this slab type is being used in the design to see the reinforcement and whatever for the slab. And now we have one panel here, this one. We are not able to define the slab type among the listed one here. So how will this slab be designed if we cannot be able to define the slab type? There anyone who have like inputs? Why or how? But it is not type 1. It must not be type 1, because type 1 is supposed to be continuous on all 4 edges. It must be the interior panel. This is at the edge. So no, it is one slab, this one, not this one. Yeah, it is continuous on only 2 directions. So can we put type 4? Cannot, because we have this. So simply, okay, I will maybe show you this when we reach the analysis part. Okay, this method of choosing the type, okay, are only applicable for regular shape of the slab. Okay, it means if you do remember even in manual calculations, when you are designing a slab using the moment coefficient method, so you have to choose, you remember in the formula to find the moments, there is a coefficient that you have to multiply. Okay, so this type defines the type of the value of the coefficient that must be used in that formula. This is only applicable for the regular shapes of the slab. So when we have irregular shape like the scenario I have here with this curved beam, we will not design a slab using a moment coefficient method. We'll have to use another method, which is a finite flow analysis. Okay. So by default, I will show it to you when we reach the analysis. Under the analysis tab, we have the normal building analysis. This normal building analysis uses the moment coefficient method. It means it is very important to define the right type of the slab. But if you have such kind of irregular shapes, in that case, you have to run this next analysis, the finite flow analysis. This finite flow analysis is the right type of analysis to analyze and design this kind of flow. Okay? So that's how it is. Good. So I think we are done with the slab. Yeah, we are done with the slab. Is there any question? Online, are we still together? Is there any question so far? Okay. There is a question for A and B. The regular slab need to set to type 1, 4, or 5. No. So if you are using the finite flow analysis, this one, it doesn't take into account the type. Okay, so even though all your slab are type 1s or type 2, it doesn't care. So this approach doesn't take into account the type of the slab. The type of slab are only needed when we are using a finite, a moment coefficient method, which are found when we are using the building analysis. Okay. So that's how it is A and B. I hope I have answered your question. Is there any other question? So let's go on then, if there is no other question. So far we have seen how to model a slant. You remember we have seen how to model a slant column, how to model a slant beam using the delta Z. Now let's see how you can model a slant slab. Okay, so to model a slant slab, so like if you want to model like a ramp, those staircase we were talking about. So you will have to use what we call plane definition. Okay, the plane definition. Good. So let's take an example. I will type my view. Okay, you remember to type view. You can pass through the view and type view. You can right click on this. You have also type view. Okay, I will type my view so that I can see the plan view and the 3D view at the same time. Good. So let's take this slab as an example. Okay. I'm going to take this slab as an example. I want to incline this slab so that this will remain, this end here will remain at the top, but this one will be lowered down to 0, 0 here. So it will be like a lamp. Okay, so that's what we want to achieve. Okay, good. So I will incline. So if I decide to use the delta Z, I will be able to incline this beam. You remember, you can use this. This is the J end. If I put negative and click on update, it will be inclined. It's okay. It's okay for the beam. It can be inclined. I can even lower down this one. But how about the slab? Because the slab, if I open the property, I don't have those delta Z to change the position. So to achieve this, okay, let me bring this back to its normal position. So that the slab may be lowered down, I'm going to use the plane definitions. Let's see how to use the plane definition. So this slab, it is this one in the plan view. Okay. So let's create a plane definition. Take a look. To create a plane definition, it is under modeling, in the modeling tab. All the way the last option under tools, you will see plane definition. If I click on plane definition, of course, I will have properties table related containing some properties related to the plane. So if you check well, the last option here, like insertion method, they are similar to the slab. You remember axis region, beam region, pick axis, pick point, and pick close slab edges. It's like the same for the slab. So what I may choose one of these. Let me use beam region because I want to create the plane at the top of this panel only. Okay, so I will check beam region. I will bring the cursor here and click on inside. Now we see P1. It means plane 1 will have been created. Okay. So please take a look here. I want you to follow. I will give you time to practice. because if you don't follow, you will be lost. Okay. So I have created the plane. If you check well, plane have always 3 points. You see, this is point 1. I have point 2 here, and I have point 3. So this point have the elevation Z. All the 3 points by default, they are 0. You see? Again, if you check here in the property, we have point 1 with Z that equals 0, point 2, Z equals 0, point 3, Z equals 0. That's how it is by default. So if you create this plane, actually in a 3D view, the plane is here at the top of the slab. Okay. So if you say that point 1 is 0, the elevation is 0, it means it is here at the top of the slab. Okay. So we'll be using these points to lower down the side where we want to lower the slab. How? So if you check well, this part here, this edge, this beam here, okay? In a 3D view, it is this beam here, okay? This beam here, maybe if I select it, you will see that it is also selected here. It is the same beam. So at this end, we don't need any change for the slab to remain there. The only end that we want to lower is this one, this edge. Okay, because we want to bring this edge all the way down here. So it means this edge will be the one to be shifted down. So if you check where this edge in a plan view, it is this one. Okay, so it means this Z, this point 3, it is only the one which needs to be changed. Okay, so how will I change it? I will select the plane. Of course, open the property of the plane to have this. So point 1, which have Z equal to 0, 0. Point 2, which have Z equal to 0, will remain 0. But point 3, which is this one, will go down in a negative sign. Okay. So how much will it go down? Because we want to start it at 0, and I know by default my story is 3. You remember yesterday I told you by default stories in Prota is 3 meters. So it means point 3, I will put it in 3 meter, negative 3 meter. If I put negative 3 meter here and click on update, you see now it have been updated to negative 3 meter. But point 2, and it is still at 0, point 1, it is still at 0. So the last step that I have to do, okay, after updating this, is to select the plane, right click, then I will have to go to move member to plane. So take a look what will happen here in a 3D view. If I click on move member to plane, I will have this one. Are you sure I want to continue? Yes. Now take a look in a 3D view how it have changed. Okay, I have like a plane, like a landing. Even the columns, even the beam have followed the plane. Okay. Good. So I will repeat this again so that you may understand it better. Okay. So this time I will work on this slab, which is this one. So this slab. So I want to bring this end here all the way down. Okay. So how to achieve that? To achieve that, I have to create a plane first of all at the top of this slab. To create a plane, go to the modeling all the way to the plane definition. Okay. Then choose the insertion method that you want to use. Then come here at the top of the slab, click so that the plane will be created. This is the first step. So by default, then comes with point 1, point 2, and then point 3. Okay. So all the points have elevation equal to 0, but remember, but this 0, it is at the top here. Okay. the value 0 is here. If you want to go down, it will be in the negative side. If you want to go up, it will be in positive side, positive direction. So for my case, because I want to lower this beam here, this side here, it means the point which are attached to that side, it is 0.1 and 0.2. So in this case, I will change the value of 0.1 and 0.2. Then 0.3 will remain at 0. So this 0.1 and 0.2 will be lowered down to -3 meters. So 0.1 will be lowered -3 meters. 0.2 -3 meters. Then I'll click on update and make sure that they have been activated. Good. Updated, I mean. If this is done, the last step to see the change is to right click, okay, then move member to plane. If you click move member to plane, are you sure I want to continue? Yes. Now we see how they have been lowered down. So let's suppose, before I give you time to do the practice, let's suppose now I will undo this, okay? Let's suppose now I don't want to lower down this side, but I want to lower down this side here, okay? For instance, I have the same scenario. Now this side is the one to go down, this beam. So in this case, we will see the point which is touching this beam, this side. It is only 0.1. So it means 0.1 is the only point to be lowered down in -3 meters. So it means if I open the property of this plane, only 0.1 will have -3 meters. 0.2 and 0.3 will remain at 0. Then update. So in this case, if I remember, take a look here. If I select the plane, right click, move member to plane. Are you sure I want to continue? Yes. Now you see the plane that have been moved, it is this one. Okay. But you see the slab is still upward. So sometimes you need to do a refresh. You have a refresh button here. So if I do refresh, it's like to refresh the view. Now will be also will follow the plane. So what you have to understand here is to understand which point among the 3 points I will be moving, depending on the side you want to move. Okay. For instance, I will repeat it here. If you want to move this downside, this one, then we'll move 0.2. You will update 0.1, 0.2. Okay. So if you want to move this here, I will update 0.2 and 0.3 only. So if I want to move this side only, I will update 0.1 only, because it is the only point which is touching this side. If I want to move this point, this side, I will only change 0.3, because it is the only one which is touching this side. So go on. Can you try take one slab which is at the edge on your model and apply plane definition, lower it down, and see if you will be able to achieve something like this. Online people, try on your side and see. Online people, were you able to model this slant slab? Were you able to do that? Please let me know if there is any issue so that I can support. A and B was able. Mariana, it's okay. That is okay. Isaac, how about you? Okay, good. And if it is okay as well. Also online, Chedi, how about you? Chedi, are you around? I need to confirm if everything is okay on your side. Chedi? Chedi, are you there? Chedi is not around again, and I think even yesterday he was not around. Okay, so let's go on. If they please class, what I want you to do, okay, is to model like a staircase. So if you have listened the concept of slanting slab and beams using the plane definition, so I want you to create like a staircase, a U-turn staircase. So it's like a lamp, if I can say, but with a U-turn. So try. So online people, you have understood what I asked. So try to make like a U-turn staircase. To see if you have well understood the concepts. So I want everyone to create this U-turn stair. Okay, please, everyone, make sure that you are doing so. Okay, so I will maybe also stop sharing, and I will do it on my PC as well, so that you may have the idea of what to do. So everyone, please do it. Many people, can you check here? I want you to do something like this. You see, it is like a stairway. So you can do it in the model we're doing. You can create something beside, but I want you to achieve something like this. Okay. So to give you like a hint, this will be 3 different slabs. This is one slab for one way. The landing will be another slab, and this one will be another slab. So it means you will create 3 different slabs with 3 different planes. Okay. So it's up to you to deal with those elevations, so that you may have the right elevations. So this will be 3 slabs and 3 different planes. So try. Okay. Many people try also, and I will see the results. For online people, I can see Isaac is saying it is done, and be also done. So those the people who are online, please take a screenshot for your model, the 3D model where you modeled the stair, and send it to the WhatsApp group. Okay. I want to see how you have created that. So Mariana, no. Okay, so I will show you how to do that. Yes, I want you to take a photo of what you have done. Okay, then send it to the WhatsApp group. the one we are in. So I want to see what you have done. So please do that. I'm still waiting for the photo in the WhatsApp group. Mr. AB, I need your photo. Mr. Isaac, please. Romeo was out in a few minutes ago. So, Engineer Romeo, did you manage to do the exercise? I see you are joining right now. Very well for Isaac, that's good. Okay. Is A and B, okay. Very fantastic, that's great. How about the remaining ones? I can only see the photos for Isaac and A and B. How about the remaining? I know Mariana didn't manage, but how about the remaining ones? Okay. Gilbert, are you there? Are you with us, Gilbert, please? Daddy, are you with us? Can you please say if we are together? Are you there? Not around. How about Chedi? Chedi, are you around? Chedi, please. So it seems like Chedi, Daddy, and Gilbert are not around. So they have logged in just today, but they are not around. Engineer David, are you there?
Yes, I can hear you, instructor.
So please follow up with Chedi, Daddy, and Gilbert. Seems like they are not here. Okay.
I kinda know. About. I have some information about Gilbert, but Chedi I can check on.
Yeah, Daddy, check on him, even Chedi. Okay. Know why they are not attending. So let me go on. Before we take a break, let me demonstrate how we should have done so that Mariana and those who didn't manage to do this task may know what should have been done. Engineer Romeo, are you there? I didn't see you in the after break sessions, but I know yesterday we were together, so I don't know the challenge you meet. So please contact David and let him know your challenges. So let's go on. I will take one panel. Let me delete this. Okay. So let's suppose I want to put a staircase in this panel here. So it will be a U shape like this one. So as I explained before, it must have 3 different slabs, okay, and 3 different planes. So that's what I'm going to create here in this pan. So I will have one flight here, another flight here, and a landing at this point. So I will use a grid, maybe offset this one, so something like this. So it means I will have a landing here, one flight here, and another flight here. So I'm going to create 3 different slabs. So I will take slab, okay, then I will have to choose the insertion method which is suitable for me, so that I can place one slab here. This is one slab. I will put another slab here, and I will have to put another slab here. Okay, so that's why I told you to be aware of all these 5 insertion method, because if I use axis region, I will only be able to place slab in this pan. That's not what I want. Okay, so I will undo. So if I use the BIM region, again I will be able to place slab in one pan. That's not what I want. Okay, so you see that it is very important to know all this, so that you may know the one which is suitable for you. But if I use pick axis, it will be I will be able to place it because I can pick all the surrounding axis like this. Okay, let me repeat. Can start by here, select this one, select this one, and lastly select this one, and the slab will be placed. Or I can even use the pick point. I can pick the first point, I can pick the second point, the third, the fourth, then the slab will be placed. So I can use any of this. So I have created slab 1, slab 2, and then slab 3. So I need to create also 3 different planes. So I will again use one of this to create a plane here, and another plane here. I will use pick point to create a 3rd panel here. Okay, so I have created 3 different slabs. I have created 3 different planes. So I want to assign every plane with the corresponding elevations. So let me time my view first, so that you can see what will be happening in a 3D view. Okay, so this is one slab, this is another slab, there's another slab. So let's start by this one. Okay, I want this one to be the one which will be at the lower part. Okay, so you know, when we are modeling a stair, it starts from 0, it go all the way to the half, to the landing. Okay, so the landing will be in the middle of this story. So you remember our story is 3 meters, so the half is 1.5 meters. So starting with this one, I will open the property of P, this plane. Okay, this point 1 and point 2, this side, I want it to be at -3 meters. Okay, so I will go point 1, put -3 meters, point 2, -3 meters. Okay, so if I do like this and update, and then do the move member to plane, it will be like this. Okay, but that's not what I want. I want that this end will be in the half of the story. So it means in the setting of P3, P6, this one, this point 3 must be in the half. So that's why I will make sure that the P3, the point 3, it is in -1.5 meters, right? So that case, if I update and then move member to plane, now it will be looking like this till the landing, right? So I will come to this P of the landing and make sure that all the 3 points are in -1.5 meters. Okay, because it is the landing. I want to lower down it to negative 1.5 meters. So I will put negative 1.5 at 1, negative 1.5 to the second point, negative 1.5 to the third. Then click on update. After updating, I have to select the member, the plane. Right click, move member to plane, accept. Now you see all the slab have moved. Now I remain with this last one. Okay. So for this side here at the front, it will remain where it is at 0, but this one will go at which point? Negative 1.5. Okay, fantastic. So it means 1 and 2 will remain at 0, but this point 3 will go negative 3.5. So I will only change this to negative 1.5. Update. Then last point is to select the member, right click, move member to plane, click yes. Then I will have something like this. Okay. So that's how it should be done. Okay. Good. So the last point I want to mention before we go for the work time. If you check well, okay, if you apply a plane definitions, even the columns, even the beams are following the plane, but sometimes you may not want that to happen. For instance, I have applied a plane to this slab, then the column have been shortened. Now you see I have an issue here. So the column must go all the way up here. So if you want to reset this, you can select the column, this column, which have a problem. If you go to the property, under the geo, you remember the property that we skipped. Okay. Now you see that under the plane top we have P3. It means this column is following the plane 3 that we defined, and that we want to reset it. It's a matter of just clicking this X button here to remove that P. Then if I click on update, take a look here at this column. If I click on update, it will come back to its initial position. Okay. So the same goes, let's say maybe for this beam. If I open the beam property under 3D, then I will have to remove the plane, make sure nothing is in the plane. Then click on update. You see now the beam have come back to its initial position. Let me do it again on this column. Make sure I go here, remove the plane, update, it comes back to its initial. Another way of doing this, if you select a member, like a column, right click, you will see where it is written reset plane definition. Reset plane definition member. If again you click on this, are you sure to do that? Yes, then it will go back. Right click, reset plane definition of member, yes, it will go back. So when you meet a scenario where you have applied a plane definition and one member have followed the plane definition and you want to reset it, that's how you would do it. Okay. So I think it is the same. So if you want to reset this, okay, so this is a very good question. Take a look here. Take a look here. So maybe I will temporarily hide this so that you can see what I want to show. Okay. You see here, we have lowered, let me bring them back. We have lowered this beam, but here the beam have been cone. So you need maybe to create another beam here at the top, because if I reset this beam, I will need again to create another beam. So normally we must have this beam which is taking the landing, and we must have another beam here at the top. So what you can do, you can just take the beam command like this and create another beam here. Sorry. So it has gone all the way down. So I can open the property, make sure the offset is known here, update. Okay. So now you'll have one beam here at the top. You'll have another one which is taking the landing here. That's how you can achieve that. So I will repeat it again on this side. Select the beam, okay? Make sure these are not applied, okay? Then draw a beam from here to here. So it will be created like this. So that's it. Is there any question before we go for the break? Online, is there any question? Mariana, have you seen how we can design that kind of stairway? Yes, Mariana is okay. How about others? So, if there is no question, so let's have a break. 1 hour, then we'll be back at 2:30. Okay. So let's have a break and see you in 1 hour. Online people, please, we are waiting for you. I need your confirmation so that we can start the training. I see Isaac is around as always. AB is always there. How about others? Mariana, are you around? Mariana, Daddy, and Shedi. Yes, Mariana is there. Good, good. Shedi. And even Daddy. Are you around? So allow me to emphasize that, okay, if you don't attend the training, you will not be certified at the end of the training, okay? So if you are not attending, don't claim for the certificate at the end of the training, right? For now, I can see that Mariana, A and B, and Isaac are the only active participants that we have on the online site. Okay. So please, the remaining ones, be around. Okay, be present for you to have the skills and knowledge that we are giving, and having a certificate at the end of the training. Otherwise, you will not be certified. Okay. Engineer Chedi, Engineer Daddy, I can see that you are still not in the room. So please. Okay. So I hope Engineer David, who is in coordination, will look at it. Okay. So let's go on and start the training. I will again share my screen so that we can continue with the training. So can you please confirm if the screen is visible, am I audible enough so that we can go on?
Yes, the screen is visible. We can hear you as well.
Okay. So please, Engineer David, maybe you will have to call the participants who are supposed to be attending online and clarify that if they are not attending as attended, they will not be certified. Okay, so please, maybe after the training, you will have to make a call and clarify that.
I've already passed on that message.
Okay, good. So let's go on with the training now. So we are done with the slab. The last thing we want to see about the slab before going to the next topic is how to create a cantilever slab. Okay, so if I go for the plan view, maybe I want to create like a cantilever slab here. Okay, so how can I achieve that? Okay, so please follow here under the modeling tab. Again, if I open the slab properties, under the type of slab, we have type 12. Okay, this type 12 means the slab is cantilever. Okay, take a look here. For now, because I have type 1, I only have 2 tabs, general tabs and load tabs. Okay, but if I change from type 1, I put type 12, which is cantilever, I will have another tab of cantilever. Okay, so if I go to this tab of cantilever, now I will be able to fill the information related to the cantilever slab that I want to draw. Okay, for it to be clear, I will draw a cantilever slab, then I will explain these settings after drawing one cantilever. So let's say if I put the length of cantilever, this is the crucial things input to do. If I put the length of cantilever, this length of cantilever is the distance. So remember, I want to put the cantilever here. So the support will be this one. So the length of cantilever is the length from the support side to where the cantilever will be ending. So I have put at 1 meter for now. Okay, I will come back. You were looking somewhere else. I saw you. Okay, so if after putting this dimension, if I click on one where the cantilever is starting, where it is ending, now I have the ability to define the cantilever is on the left side or on the right side. So it is on the left side, then I put the cursor on the left side, then click, the cantilever slab will be created. If I go to the 3D view, it will be looking like this. Okay, so I will repeat it. Now check. Just now check here. So under the modeling, if I click on slab, okay, under the type of slab, you have to choose type 12. Okay, type 12 is for the cantilever. So if you click on 12, now you'll have the tab for the cantilever. So we can click on cantilever and change the length of cantilever. Okay, so if I put 1.5 for instance and draw, now it means the 1.5 was from this end all the way to this end. Okay, so that's how you can draw a cantilever. So let's take a look at these dimensions as well before you take a time to do a practice. We have D and B slab. What is D and B slab? We have already seen that the length of cantilever is from this support all the way to this end of this is the end of cantilever. So the B slab, this B slab, it is from where it is starting here all the way to where it's ending. Yeah, so this is the B of the slab. So for instance, if I put let's say 2 meter, and sorry, I will have first of all to select it, open its property, then on B I will put 2 meter and update. You see how this slab have been shortened. So it means from this point all the way to this point is only 2 meter. Okay. So if I put 0 and update, it will span all the way up to here. So if I want to define, because every time the cantilever slab is not starting at this column to this column, it is not spanning all the way, all the length. So in that case, I will have to use the B slab so that I can define the width of this slab that I want to use. Okay. Then lastly, we have the D, which is the distance. So this is the distance from where the slab is starting to where where the span is starting to where the slab is starting. For now, it is 0. That's why from this point here to where the slab is starting is 0. But if I put like 1 meter, for instance, okay, and then update, now you see it have been shifted. So you must understand very well the difference between this. The length of cantilever, it is from this point where we have a support to where the slab is ending. The B slab, it is this length of the slab from this point to this point. Then the D, which is the distance, it is the distance from this origin point to where the slab is starting. Okay, so in this case, that's how you can model slabs, okay? Cantilever slabs. And in a scenario where you have like let me see, where you have like a corner. Let me try to reset this. I will need this. In a way where you have the corner like this, if you are choosing to create cantilever slabs, okay. For instance, from this point to this point, I will create a slab here. So if you create another slab here, the software will join those slabs automatically. So if I create another one here, you see automatically there is connection. So in a 3D view, it will be looking like this. Okay, cantilever slabs. So try it on your end. Then if everything goes okay, we will be ending with the slab. Then we go on with other concepts. Try on your end to deal with cantilever, and if you meet any problem, let me know. I will help you before we proceed with the next topic. So is everything okay with the cantilever slab? So I can see that we have a question here online. They're asking what type of slab should be assigned to staircase landing slab. What do you think, guys? So if you have this slab here, okay, what kind of slab type should be this slab type? This one on the stair, like what we have here. What slab type? So they're asking if you are modeling this so under the slab type, which one? So someone is saying type 7, is it right? So type 70 means the two short edges are continuous. So it should be type 7 if this is continuous and this one is continuous. And it is not the case. So among all the slab type we have here, we have two special types. Okay, type 12 we have seen that it is for cantilever. Then there is type 0, if I can say, the first one with the two arrows. These are for one-way slabs. Okay, so for instance, if I click on this, okay, and update, see it is for one-way slab. Good. Can you try it? This one, okay, it's for one-way slab. So, but what I want to mention here, for the staircase, okay, please understand this very well. The purpose of modeling these kind of lamps, okay, it is not for the purpose of designing a stair, right? We only do this so that we can apply the load coming from this slab to these columns and beams here, okay? But when it comes to designing the stairs at their own, to know the reinforcement, the diameter, and whatever, we will do it in Protadetail. So the calculation for the stair design is done in Protadetail. The only reason of doing this in Protastructure here is to take into account the loads of this staircase to the member which is attached to the staircase. It means the columns here, this beam supporting the landing and whatever. Because we'll be needing to design this beam which is supporting the landing. So it must have the loads which is coming. Okay. So that's the only purpose of modeling stairs as lamp in infrastructure. But to have a complete design of a stair, it will be done in Protadetail. We'll see it on Friday. Okay. I think I have answered your question, Mr. A and B. So if there is no other question, allow me to go to the next chapter, if I can say. So for now, we are done with the basic of modeling. So we have seen how to model grids, how to model columns, beam, and solid slab. Even walls, shear walls. So the next topic will be working with other stories. Okay, so because you have seen that everything you have created so far are on story 1. Okay, this ground. So how to create other stories, how to model element on the upper stories. So that's what we are going to see. Okay. So when you open a new project, Protastructure, by default, it have story 0. Take a look in the structure tree. So if you have many things in structure tree like this one, so try to click on triangles to collapse everything, so that remains only with the. Okay. Try to collapse everything, so that you'll be able to see the story 1 and story 0 here. Okay. So I was saying that when you create a project in Protastructure, by default it comes with story 0 and story 1 only. Okay. So this story 0 is the foundation, okay, the foundation level. If I double click, you see how the grids have moved to the bottom here, okay? Because story 0 is the one which is activated. If I want to activate story 1, then I have to come here and again double click on story 1. Now you see how the grids have moved to story 1 level. Okay. If you do it when you are in plan view, now story 1 is activated. If I double click on story 0, it will activate the foundation level. If I double click on story 1, then it will activate the story 1 level. Okay. So let's see together how to create other levels or other stories. So we have many ways of doing such actions. So the first one, okay, is by going to the building setout. Building setout, all the way to stories, you will see story operations. Under building setout, all the way to the right, you see under stories, you see story operations. So we are going to see all these story operations. Select story, insert story, remove story, delete story, and generate stories, even edit story. So we are going to see all of this. These are the operations which are related to story management. Okay. So this is the one way of getting all these options. Under building setout, under story operation, you will see this. Another way, okay, under the structure tree, you locate stories. There is a title called stories. If you select it and right click, again you will see the same command as the one you will be seeing when you use these story operations. So it's up to you either to pass through the building setout and open the story operations, or just by right clicking the stories in the structure tree, you will have them. Okay. So let's start by insert story. So insert story, it means we want to create other stories in our project. So let's start with insert story. I will go to insert story. If you click insert story, you will have this box. Now simply under story number, you have to put the number of stories. Okay? But pay attention here. You don't put the number of story that you want to add, but you put the total number of the stories. So for instance, for example, if I want to add 2 stories, for now we have story 1 story. I want to add another 2 stories. So the total will be 3 stories. So that I will write 3, not 2. Okay? So you don't input the number of stories that you want to add, but you put the total number of the stories that you want to have in your project. Okay, so for instance, if I put 3, it means I'm adding 2 stories to the story 1 that I had. The total will be 3 stories. So I will put 3 and click on OK. Have this warning. You have always to read these warnings. I'm telling you, the previous process will not be undone. It means if I click yes and use this undo, Ctrl Z, I will not be able to go back. So are you sure you want to continue? Yes, I'm sure. Now if you double check in the structure tree, I have story 1, story 2, and story 3. Okay. Good. So now you see that under structure T I have created. So please note that. So whenever you are inserting a story, the number that you have to put here is the total number of all the stories that you want in the project. Okay. So now, for instance, now I have 3 stories. So if I want to add another 1 story, okay, I want to add another 1 story. Which number should I put here? Yes, it must be 4 because after adding that 1 story that I want to add, the total number will be 4. So in that case, I will have to put 4. Then, okay, now I will have the total number of story being 4. Okay, so that's how you can add stories. So if you double check in my 3D view, now the axes are located in the air here, they are like suspended. This is because the activated story is 4. How can you know that the story which is activated is 4? You can double check on this title here. You will see 4 is activated. Or under structure 3, you will see that the story 4, it is one which is activated because it is the one which is like bold. Okay. So now I can know that story 4 is the one which is activated. Good. If I want to activate another story under structure 3, you have to double click it. So if I want to go from story 4, take a look. I want to go to story 3. If I double click, now story 3 is activated. Activate story 2, double click. Now story 2 is activated. Story 1, now it is activated. And then double click on story 0 to activate story 0. So the same goes even in the plan view. For now, story 1 is activated. If I double click on story 2, see, I have only grids. I don't have any member created yet on story 2. Same goes for story 3, even story 4. But if I come back to story 1, because I have already created some members, I will be able to see those members. So can you try creating stories? Take like 2 to 3 minutes, just create stories and see. Good. So let's go on. Then let's take another story operations. Okay. Again, under the stories in the structure tree, right click to see all the story operations, or under the building setout story operation, you will again be able to see it. Okay. So I'm using the one in the structure tree. Then the next one will be generate stories. Okay. So simply generate stories means do a copy paste of members. So you are going to copy some members from one story and paste them in the other story. Simply let me tile my view so that you can be able to see what I mean. If you see on the left side, I have the plan view of story 1. If I want to model columns and beam and all the members on the upper story, so I have to activate story 2. Okay, so I have activated story 2. Now I can go to the modeling, start creating again members as I did before. So if I click on member here, place a column, you see in a 3D view, it have been also placed. Okay. So if I put another one here, you see here in a 3D view, they are being placed on story 2. Okay. So you can decide to place this manually like this. Okay. But if for any case you have like similar stories, maybe some members on the, because you know mainly members like columns are continuous. Okay, so you can copy those members from one story and paste them to the other story. So that's what we are going to do. So I will delete this for now. Okay, instead of doing this manually, I'm going to copy and paste. So copy and pasting, I will be using this generate stories. So what I have to do, go to the stories under structure tree, right click, generate story. You will have this box. Okay, so I'm going to explain this box, dialog box that we have. We have two columns here. We have the source story and the target story. So the source story is the story where you want to copy element from, where you want to copy. Okay. Yeah. Do you have something like this? So if you come in here under stories, select, then right click, you generate story. Okay. In the structure tree, you will see stories. Great. So I was saying that we'll be having two columns here, the source story and the target story. Okay. So the source story is the story where you want to copy element from, where you want to copy element. For my case, because I have already modeled the member on story 1, so the source story will be story 1. Okay. So the target story is where I want to paste the story, where I want to paste those elements. So I can select only story 2 or only story 3, or I can select both. It depends on what I want to achieve. So I'm selecting the source story to be story 1. Then the target story, I'm selecting all the story that I have there. Okay. Good. So story 2, story 3, and story 4 are selected. Now here I have a list of members. So you have to define which member you want to copy. If you use this button here, select, deselect all, you can select all member or deselect all member, like so. Okay, using this. So it's up to you to choose what you want to copy and paste. So if I select column, it means all columns on story 1 will be pasted to the remaining stories. So for my case, I'm going to just select everything. Okay. Then click on OK. So take a look in the 3D view here. If I click on OK, I will get this warning. Click yes. See how it has been populated. Make sure you see this message that process is completed. Now I can close. So if I go to the 3D view, now I have a multi-story building looking like this. Good. So all the elements that I had on one story have been copied and pasted to the remaining stories. So that's the generate story. That's how you can generate. So if you are dealing maybe with like an apartment, mainly apartments floor are similar, you just model one floor, then you copy paste. Yeah. And you are still free to do modification. For instance, maybe I want to delete this cantilever slab on the last story only. If I delete, you see, the remaining ones will stay there. So I can still edit a story as I wish, independently. Okay. So that is a generate story command. Good. Okay. However, what I can advise you, before doing a generate story command, before copy pasting, you have to make sure that there is no errors on that story, because if there is some error, then it will be duplicated to the other stories. So make sure everything is okay before doing copy paste. Tomorrow I will show you how you can identify some modeling errors that you may have done. Okay, I will show you tomorrow how you can identify some modeling errors using a building model check. So that was the second command. So let's go on and see the remaining ones. The next one is delete member in a story. So as you can understand, it is deleting member in a story. So we have two options here. Take a look. Delete member in a story and remove story. So they are almost similar, but they are different. Okay. The first one, delete members in a story. It means you will be only deleting members, but the story will remain there. Okay. You are only deleting members within a story. But if you use the second one, remove story, it means you will be deleting the story, even the member inside that story. Okay. So, for example, if I take this one, delete member in a story, I will have this dialog box. Okay. Then I'm going to delete all the members on story 4. So I will select story 4. So it is the one selected. If I click on OK, take a look here in the 3D view. If I press yes, now all the members on story 4 have been deleted. So the story 4 itself remains still there, but the members have been deleted. So if you want to delete members in a story, don't bother yourself coming here, selecting everything, going to delete and whatever. So you can just use this command under stories, delete element in a story. Select the story that you want to delete element from, story 3 for instance, click OK, accept the condition, then all members will be deleted. Okay, can you try that? Can you try that? Can be done. But you have to add the members to support the hanging story. Okay, so the next one was the remove story. Okay, so remove story now. If I click on remove story, again I have to select the story that I want to remove. Okay, let's say story 2, 3, and 4. I want to remove them. In this case, they will be deleted, and the member within those stories will be deleted as well. So I have selected story 2, 3, and 4. If I click on OK, now they have been deleted. And if I check where in the structure tree, I only remain with story 1. Story 2, 3, and 4 have been deleted. Good. Good. So try on your computer, play with this story operation that we have seen. Insert story, generate story, delete member in a story, and remove story. So try to work on it like 3 minutes, 5 minutes. Then we will go on with the edit story command. So let's if there is no question, is there any question? Online people, is there any question? So if there is no question, let's go on. Let's go on with the remaining story operations, which is edit story. Okay. So if you click on edit story, again we'll have a table like this one. Okay. And I have only, under my list, I have only story one because I only have story one. So to explain this more, much better, I will create other stories so that I will have a list of 2 or 3 stories. So I will again insert story, let's add like some more story, then go to stories and edit stories. So now I have 3 stories on my list. Okay. So I have told you that the default settings, the story height for the story one is 3 meters. Okay. So even if you create the additional stories, by default, they are 3 meters, 3 meters. Okay. But you have ability to do the modification to those stories height using the story editor. Okay, so you can see here where we have H on this column here, we have the height of our stories. Okay, so let me maybe explain starting from the first column where they have info columns. So you see for my case, story 1 is ticked, but story 2 and 3, they are not ticked. Okay. So simply when you have a ticked story, it means on that story we have some members. So because I don't have any member on story 2 and 3, that's why they are not ticked. Okay. The next one is about stories, name of the stories, 1, 2, and 3. Then the next one is about the height of the story. So if you select on one of this height, you'll be able to do what, to change the height. For instance, if I say this story 1 will be 5 meters, for instance, if I put 5 meters and click on OK, now this, you can see how my columns have been elongated. It means the story will increase and the member will follow the story. So you don't need to go back and adjust the height of all the columns. So whenever you change the story, the member will adapt. Okay, so now you can see how these columns have been somehow elongated because now the story is 5 meters instead of 3 meters it was before. So if I go back again to edit story, bring this back to 3 and click OK, you see how my story 1 have been shortened again to its initial position. Okay, this will only affect the members within that story. Go back here, so you can always change this height. If you change the height, of course the level will adapt. Okay, the level will adapt. So the next one is the labeling. You remember from the starting, let me show you. When we were on story 1, you see the column were named 1C, 1C1, 1C2, and whatever. Even the BIM 1B1, and so on. So this one, which is in the front, you remember where I told you that it was representing that we are on story 1. Okay, but sometimes you may model like a building which have, like, let's say how do you call it, the basement. Okay, if this is like a basement, let's say, and you are naming your members 1C1 and 1B1, it may be somehow confusing, because mainly when you see one, you understand that you have ground floor. So if it is a basement, maybe it will be somehow confusing. So you have the ability to change these labels. So to change these prefix labels, it is done under this story, edit story, this labeling here. Okay. So if I change where we had 1 and maybe put, let's say 0, click OK. Now all the members will be named as 0, C1, 0, C2, and so on for a column. You see for BIM also it have been adapted, even for walls. Okay. So for any certain occasion, okay, or scenario, if you want to change this labeling, you are free to do so under this label here. Okay. Let me put it back to 1. Then the next one is the description. So description is just you want to add some few words maybe for you to be much clear. So for instance, for the description, I can come and maybe write this ground level, let's say. If I click, I tap in ground level and click on OK. Take a look here. Before we had story 1, okay, but this description will be added to the name. So if I click OK, now my story 1 is named as ground level. Okay. So if you want to add those kind of description, you can do it under this edit story. You can say ground level, first level, second, and so on, if you wish. Okay. Then the next columns, we'll not talk about it right now because it is a little bit advanced. This D1, wall 1, and whatever. This imposed load reduction. So we'll not talk about it. This, okay, it is a little bit on advanced topic. So these are the values you will be using this when you will be dealing with seismic design. Okay, so we'll not cover this at this is not on our curriculum for this intermediate level. But whenever you're dealing with those seismic design, then we'll be dealing with these values as well. For our case, we are not concerned with that. Then, as we have changed these settings for the related to the height, the label, and the description, this was for the superstructure. But for the foundation also, we have the same, but it is located here, down here. Okay. So we have the foundation depth. Okay. So the foundation depth, the length of that subcolumn under the soil. So you have a flexibility to change it. Okay. By default, it is 1.1 meter, but depending on the soil investigation, then you will have to put the correct foundation depth. Okay. Then we have the footing label, which is F. This label is like the label we had here. It means when we will be creating footings, it will have F as a prefix. Okay. Then we have the footing description. You can add a description as we did here for the superstructure, maybe say foundation. So if I put foundation and click OK, it will be also be found in the structure tree as foundations. Okay. You see that we have many things that we can edit under the story edit story. Okay. Are we good so far? In edit story, we have seen how you can modify the story height. Okay. How you can add these descriptions. How you can even change this label of the member within a story. For the footing part, the foundation part, we have seen how to adjust the depth of foundation, its description, even the label. Are we together so far? Okay, good. So let's go on and see something else which is very interesting when it comes to a multi-story building design in Protastructure. You have seen how you can generate stories, okay? But suppose that this is one story that I have, okay? I have other, let's say, let me set maybe 6 stories, okay? And now all the stories are similar because maybe I'm designing an apartment building. Let's say I want to generate everything from story 1 all the way to all remaining stories, okay? And it is something like this, okay? But at the end of the time, I realized that I have done a mistake, okay? Maybe there is something I want to change, okay? So if I found that there is something I want to change after having a big structure like this, I will have to change that thing on each and every floor at every story. So for instance, I found that this is an error, okay? Then I had to maybe to reset this so that the BIM can go back here, and I have to reset this so that the column may go all the way like this. And maybe I want to delete the remaining part like this. Yeah. So I will be obliged to do the same on every story, okay? On every story. So there is a way of telling the software that your story are similar, so that any change you will be doing on one story will be automatically duplicated to the other stories. Okay? So it is very important to use that features when you know that your story are identical. You have to define them as similar, so that whenever change we'll be doing on one story will be duplicated to other stories. Okay. So how to do that? Again, it is under edit story. Okay. It's under edit story. So take a look here, check. We have a similar story column. And we have defined story settings here at the bottom. So I will be using those. So I want to define all my stories to be similar. Okay. So what you have to do is to select the stories that you want to make similar. So for my case, I want all of this to be similar. So I have selected the stories. After selecting this, I will define a selected story as similar. it is not mandatory to select all. Maybe if I wanted to select only story 2 and 3, then I would have done so. Okay, but for this demonstration, let me select everything and define selected story as similar. So if I click there, I will have this dialog box. Okay. So it is just telling me, I will try to explain this. This warning, this dialog box is just communicating that I want to make all the stories similar, but I have already modeled some elements on those stories. Okay. So among those modeled elements on different story, which story I want to take as a reference. Okay. So among all the stories, which one I want to take as a reference. I may take any of this. Let me maybe take 22 and click OK. If I click OK, now you will see here under the column where we had similar story, we have some numbers. So simply these numbers means that story 1, this story 1, is similar to story 2, 3, 4, 5, and 6. Story 2 is similar to these stories which are at the column, and so on. Okay. So the last thing is to accept this. That's what I wanted to achieve. Click on OK. We get another warning. Are you sure I want to do this? Yes. Okay. Then we get another one. This story will be changed. Okay. Do you want to continue? Yes. Good. Then you will see that I still have the same model, if I can say, but the difference is now the software knows that all these stories are similar. So if I click on one BIM and delete, they will be deleted on the remaining stories. If I select only one slab and delete, they will be deleted on all stories. So any change I will do on one will be applicable to others. So if I select this BIM, maybe reset its member, reset to member definition. So it is not working. Maybe I'll delete this. Delete this. Okay. So now you see that any change that I do on one plane, it is being duplicated. So I can come here. Let me make sure. If I come here on plan view, I decided to put maybe a BIM. Okay, a BIM here. So this place it is here. So if I put a BIM like this, okay. So you will see that it will be also placed on all the floors. Okay. So now in this case, you are sure that you have multiple floors, but you can work on one floor, knowing that the work you are doing is being duplicated to the remaining floors. Okay. So try to make your floor similar and see if you'll be able to achieve the same result. Try. Try. Try and see if we achieve the same result. So, online people, can you please confirm if everything is okay so far? If you were able to manage doing making story edits, making them similar. Okay. Okay, AB, it's okay. Isaac, we are together. Great. How about others? Shady and Daddy, how about you? Mariana is okay, good. Shady Daddy, are you there or you are absent as always? Okay, so take a look here, okay? We have made all our flow similar, okay? However, because this is the top roof, I want to close here, so that will be a slab. This panel, I must close here and this one, okay? I'm just challenging you, okay? So if I go here to the last flow, if I try to put a slab here to cover this hole here, if I put a slab here, now normally this slab have been going to all the flow because we have defined them to be similar, okay? And I want to put only slab on this part only. So how can we do that? How do you think can we achieve that? Because if I select, let's say, like this, okay. Let me show you something here. Okay. You can in Protastructure you have the ability to temporarily hide some element. For instance, I want to see the inside of these shear walls, so I can select this, right click, and hide selected. So it is not deleted, but it is hidden temporarily because I want to see the interior of this. Then I can hide selected. I just wanted you to show that when I placed this slab, it was placed on all the remaining floor. So how can I place, because I have already defined my floor to be similar, how can I now tell the software this time I want to put only slab on the last floor only? Okay, good. Say we have to counter the similarity for the last flow. So how to do that? Again, it is under story edit story. Now, because we have seen that the last story we want to do some modification, then I will select the last story only and reset the similarity. Here we have a reset button. Okay. A reset. Then I will reset. Click on OK. Are you sure? Yes. Then in this case, if I delete the remaining slab, this one will be remained. So any change I can do on this last flow will not affect. You see, will not affect the remaining stories because I have resetted the last story to not be similar. You can even decide to reset everything back to the way it was before. Can select every story, then reset, click OK. Now this time each story will again be independent. Okay. So to bring back the shear walls that I have hidden, just right click and click show all. They will be shown. So today we have covered a lot. Okay, we have covered a lot of it. So you need to do practices. You need to do practices. So I will give you time to do like practices for all what you have learned today and yesterday. Okay, but let me show you like hints. Okay, before we go for the exercise time or practice time. So what I want to show you, yeah. You see, because we have many flow, now we have many members, a lot of members in our view. Okay. So the first tip that I wanted to show you is that one that I showed you in a few seconds ago. If you want to hide some members, for instance, this member, I want to temporarily hide it. You have to select it, right click, then hide selected. It will be temporarily be hidden. Okay. When you want to bring it back, right click, then show all. It will be visible. You can also decide, okay, to hide everything except the selected one. In that case, it's like an inverse. You will select it, then show selected only. In that case, everything will be hidden. Then you will be remaining with this one, and you work on it independently as you wish. If you want to bring everything back, then right click, show all. They will be back. So this is very important. You will be reading this way when you will be working on a more complex project. For instance, I can only want to work on this stair, so I can only select this stair. Yeah. Then show only selected. I will remain on only with this. I can do my modification as I wish. Then if I click on show all, everything will come back place. Right. I can now decide to show only one flow, because that flow I want it to work on it in 3D view. I can now decide to show only one flow. So it is achieved by using right click and isolate story. So if I click on this, everything will be hidden except one story. Okay. If I activate story 5, only story 5 will be there. If I activate story 0, then only story 1 will be there. You can even activate different stories using a Ctrl plus arrow key, okay, to change between stories. If you want to bring everything back again, right click, isolate and isolate stories, and everything will be back. Good. Another way you can hide some elements is by using the layer, the display. So if you come here under display tab, you will find different layers here. Okay. So by default, all layers are visible, but you can decide to hide some and leave others. For instance, if I don't want to see shear walls, it's a matter of coming here to shear walls, deactivate and all shear walls will be disappeared. Maybe I don't want to see beam, I don't want to see axis, even slab. I only want to remain with column. So I can achieve that. You can only open shear walls, okay? Then close slab, close. So we have only shear walls. So you have a flexibility to do this. Decide what you want to view and what you want to hide. Yeah. Now, like this, I'm able to see only slabs, shear walls. Then you can turn everything back to active. Okay, so it is achieved via the display tab here at the top. Good. So that was the hint for today. Then it is your time to ask questions before we go to the exercise time. So online people, if you have questions, write it down. In physical participant, if you have question, just call me. I will come help you on your desk. Before we move on with the last topic of today. So let's take the remaining minutes to do practices. Okay, so I will give me like 5 minutes. I'll be sharing the document in the WhatsApp group. So what we are going to do, okay? So we are not ending today's sessions, okay? Please, everyone do this exercise, even those who are online, okay? So what you will do, you will open a new project, okay? Save the work you were doing. So we are going to start a new project. So I'm just going to share you a simple drawing of architect, okay? So what you are going to do, start modeling that house, okay? What I need you to do for now, in the remaining 1 hour, we will be creating the grids, okay? Then create columns, beam, and slab for the first floor only, okay? As simple as that. So create a new project, give it a name, define the template that we'll be using, the code, then start modeling. So give me like 2 to 3 minutes so that I can share the document in WhatsApp group, okay? I will be around, I'm still here, so if you meet any challenge while modeling, so feel free to tell me. And you need to do this, all of you, so it will help you to understand at which level are you so far in modeling. So please check your WhatsApp.